So we are back to the online class, right? So today it is continuation, equilibrium. Okay. So whether it is visible? Yes, yes. So equilibrium topic we are going to continue. Fine. So shall I start? Shall I start with the class? Okay. Now, in the previous class, we have solved some of the problems related to equilibrium constant. Now, today we are going to discuss about factors affecting the equilibrium constant. Okay, we are going to discuss about the factors affecting equilibrium constant. Okay, so that's what we are going to discuss today. Now, naturally, when I am talking about the factors which can affect the equilibrium constant value, so the first one will be concentration. First one will be the concentration. So, concentration of what? Concentration of reactants, and products involved in that reaction. So that's where it's going to decide the equilibrium constant. For example, I will take a reaction A plus B getting converted into C plus D. Okay. Now the reaction is taking place. For that, equilibrium constant value will be C into D. I have not given any of the stoichiometric coefficient, A and into B. So that's why we have the equilibrium constant. Now what we can do is, if I am going to add extra C from the outside, extra C and D from the outside. Now what will happen? Naturally, reaction will shift towards the leftward direction. Try to understand this. So what I am telling here is, this is the condition. At equilibrium, we have the sum of the concentration of C and D, A and B is there. We have got the equilibrium constant value. Fine. Now what I am going to do is, we are going to add any of the one of the product or C and D. Both we are going to add to the solution. Now naturally, since there is an increase in the concentration of C and D, now the reaction will start move towards the leftward direction. Or if I add more amount of A and B, now the reaction will move towards the rightward direction. So what I mean to tell here is, depending on the concentration of A and B, or depending on the concentration of C and D, either reaction will move towards forward direction or it will move towards the backward direction. That is the effect of concentration on equilibrium constant. That will be the effect of concentration on equilibrium constant. Now, one statement I will make it very clear. When it comes to equilibrium, chemical equilibrium, initial concentration will not have effect on the equilibrium. Initial concentration will not have effect on equilibrium. Don't get confused. Okay. So whether I have started the reaction with 1 mole and 1 mole of B, or 0.5 and 0.5 mole of B, that's not going to affect the equilibrium. Okay, initial concentration will not going to affect the equilibrium. That's what the statement is meaning. Fine. But when I am talking about reaction which has reached to the equilibrium, now if I add any of the product or any of the reactant, then it's going to disturb the equilibrium. So that's what the effect of concentration on the chemical equilibrium. But once again I will tell, but whatever the initial concentration has started the reaction, that's not going to decide equilibrium. Okay, that's not going to affect the equilibrium. Equilibrium will be affected once it has reached. Then if you add any of the product or any of the reactant, then it's going to disturb the equilibrium. It's going to decide whether forward reaction or backward reaction. Fine. Any doubts with regard to this one? Effect of concentration. And don't forget about that initial concentration, whatever I have mentioned. Any doubts? Okay. So in that case, I will move to the next one. I will move to the next one. So, next one is with respect to temperature. Yes, done. Thank you. Next one is with respect to temperature. Whether temperature will have any impact on the equilibrium. Okay. So naturally, when I am talking about the temperature, it will have the impact on the equilibrium, no doubt. Right? Because majorly we have two types of reaction. One is exothermic reaction, okay, and another one is endothermic reaction. Exothermic reaction and endothermic reaction. When I am talking about exothermic reaction, in case of the exothermic reaction, heat will be liberated. All of us we know. There will be liberation of heat. So heat will be liberated. Those reactions are called as exothermic, which we have discussed in thermodynamics. So what do you mean by endothermic reaction? Endothermic reaction is where heat will be absorbed. Where heat will be absorbed. Right? See, for example, I have sodium hydroxide and I will add it to the water. It is an exothermic process because heat will be liberated. The vessel will become hot. If I add acid to the water, once again there will be liberation of heat because it is an exothermic process. But if I take alcohol, ethanol, I will put it on my skin, then we are going to feel cold because during the evaporation of this alcohol, it will absorb the heat. So due to that, we are going to feel coldness in that particular area. Same way, I will take two organic solvent. I will mix them with each other. So during that time also, the vessel will become cold. Once again, endothermic reaction because heat is getting absorbed. So that's what. In case of chemical reaction, we can have exothermic reaction and endothermic reaction. For example, once again, I have a reaction where A plus B getting converted into C plus D. And we will imagine that there will be liberation of heat during the reaction. There will be liberation of heat during the reaction. Now, if I provide the heat from outside, this reaction, will imagine it is taking place in a test tube. So what we will do is we will put it in under Bunsen burner. We are going to heat the test tube. What do you think? What will happen? Anyone? What will happen? If I am going to heat the solution, what will happen to this reaction? Whether forward reaction will happen or backward reaction will happen. So according to this, A plus B reacts with each other to form C plus D. And during that time, there will be liberation of heat outside. Okay. Now what I am telling here is I will heat the test tube where this reaction is taking place. So what do you think? What will happen to the reaction? Whether forward reaction will take place or backward? You can just mention forward or backward. What will happen? Okay. Gahan is telling forward reaction. Ashish is telling backward reaction. Okay, Rohan, forward. Okay, so I will make it very clear. If that is the case, Ashish is correct. It should be backward. Try to understand. Reaction will shift towards the backward because in the forward reaction by itself, due to the reaction itself, heat will be liberated. But if you are going to heat the solution itself, now due to the supply of heat from outside, the reaction will shift itself in such a way that where less heat should be liberated due to the reaction. So naturally it will be in the backward direction. It will be in the backward direction. Try to understand this one because at the end I am going to brief out one of the principle based on all these things. Got my point? So what I mean to tell you is whatever equilibrium was with respect to forward reaction, now exactly it will be reversed. So that means 1 minute. Okay. So whatever forward reaction is there, based on that we have got the equilibrium value. Fine. So according to that we have got Kc is equal to C into D divided by A into B. So this is the equilibrium constant value. Now due to supply of heat from the outside, naturally the reaction will push towards backward direction. That means it will be reversed. Equilibrium constant will be reversed. A and B, now it will act as a product now. Okay? For the backward reaction, reverse reaction, A and B will act as a product. That's what. So there is an impact on the equilibrium. There is an impact on the equilibrium. All of you have understood? So what I mean to tell you is for exothermic reaction, if you supply the heat from the outside, backward reaction is going to happen. And for endothermic reaction, if you supply the heat from the outside, then forward reaction will going to happen. Fine? Whether I am clear? So therefore I can make a statement. So if I supply the heat for the exothermic reaction, it will shift towards the backward direction. And at the same time, if I supply heat for the endothermic reaction, then it will shift towards the forward reaction. Fine? So you should remember this one. That is the impact on the equilibrium related to the temperature. So definitely temperature is going to have the impact on the equilibrium value. Fine? So in earlier case we discussed about the concentration. But concentration will not have impact on the, or initial concentration will not have impact on the equilibrium. But that is not the case with respect to temperature. It is having the impact on the equilibrium. It's going to decide whether it will be forward or backward reaction is going to happen. Fine? So therefore if you remember many of the reaction in organic chemistry, we used to mention the temperature and all. Some of them used to be at low temperature, some of them used to be at higher temperature, right? So that depending on the requirement, temperature will be supplied or temperature is going to be decreased. That is the impact of temperature on equilibrium. Fine? Any doubts? Okay, so we will move to the next one, that is effect of pressure. Effect of pressure on the equilibrium. Effect of pressure on the equilibrium. briefly, I have discussed this one before itself. While starting with the chemical equilibrium topic, we had briefly discussed about the pressure, effect of pressure on the reaction. The best example for this one is, I have nitrogen which reacts with hydrogen to form the ammonia. So this is nothing but a Haber's process, where nitrogen is reacting with hydrogen to form the ammonia. Now if you observe it carefully, this reaction where if I supply the pressure somewhere around 20 kilopascal pressure they used to maintain, right? So if you are going to supply that much amount of pressure, naturally the reaction will happen in the forward direction. So to avoid the confusion, I will do like this. If I supply 20 kilopascal of energy, very high amount of energy it is. So 20 kilopascal of energy, then the reaction will be moving towards the forward reaction vigorously. Okay? So concentration of product is going to increase drastically. What is the reason? The reason is very simple. If you observe on the reactant side, we have 4 molecules of gaseous molecules. 4 gaseous molecules are there. But if I observe on the right hand side, we have the 2 molecules, gaseous molecules. So if you observe it carefully, where the number of gaseous molecules are more, whether on the left hand side or on the right hand side, naturally it is on the right hand side. So therefore when I am applying the pressure, reaction will adjust in itself in such a way that where less number of gaseous molecules are there, that side the reaction will be shifted. Once again I will repeat. When I am applying such a high amount of pressure, now what will happen? Whatever gaseous this reaction is there, it will adjust itself in such a way that where less number of gaseous molecules are there, the reaction will be shifted towards that direction. That means in this case, forward direction towards the synthesis of ammonia. Got my point? That is the importance of pressure in this particular reaction. Okay? So therefore, in some of the reaction you might have observed, they will be showing the amount of pressure also, reaction condition. So that's where to have the maximum product formation. Okay, that is the impact of the pressure. Say for example, you will take a balloon. Now that balloon which is filled by the air, apply the pressure on the balloon. So what will happen? Other side of the balloon will be bulged because those gaseous molecules will move away from the pressured area. So they will move to the other side. So other side will be bulged. Same logic is applicable here. That is the feature of the gaseous molecule. Whenever you apply the pressure, it will try to move away from the pressure area. Right? So therefore reaction will adjust in such a way that where less number of gaseous molecules are there, it will shift itself towards that direction. Fine? That is the impact of the pressure on the equilibrium. Whether I am clear? For example, without pressure, we'll imagine that Kc is ammonia to the power of 2, then nitrogen to the power of 1, then hydrogen to the power of 3. Right? It might be in the absence of the pressure. So naturally some ammonia will be formed, nitrogen will be there, hydrogen will be there. So now when I am applying the pressure, naturally Kc value is going to increase because numerator value is going to increase. Product is going to increase. Fine? So therefore, before applying the pressure, Kc value will be something, but after applying the pressure, Kc value will become like this, which will be greater than earlier equilibrium constant value. Imagine that Kc prime is the equilibrium constant value once the pressure is applied. So naturally Kc prime value will be greater than that of the Kc value. Okay? All of you have understood? Any doubts? Any doubts? Oh. Correct. Now the last one. Last one is related to catalyst. That will be related to catalyst. And for biology students, you people know that when it comes to biological system, it will be called as enzymes. Okay? So catalyst is a general name. If I go with biological system, then it will be called as enzymes. However, when I am talking about the catalyst, whether really catalyst will have impact on the equilibrium. Once again, I will take the same reaction. Nitrogen, hydrogen, then we have the condition, then two molecules of ammonia will be formed. For this reaction, we are going to use the catalyst iron oxide. For this reaction, we are going to use the catalyst as iron oxide powder, which is an example for heterogeneous catalyst. Anyway, we are not going to discuss in detail, but this is the reaction. Now, for this, Kc value is decided by the concentration of ammonia divided by nitrogen into hydrogen to the power of 3. Okay, so this is the Kc value. Now, I will make these reactions to happen in the absence of the catalyst. In the absence of the catalyst. So, for that, Kc prime value I will take it as NH3 to the power of 2, then nitrogen, then hydrogen to the power of 3. Okay. So Kc prime, whatever Kc prime is there, it is in the presence of the absence of the catalyst, and this is in the presence of the catalyst. First reaction, second reaction. Now I will make it very clear that the value of Kc and Kc prime will be same. It will be same. So then what is the use of the catalyst? The use of the catalyst is it helps in attaining the equilibrium at faster rate. Please remember, catalyst will not going to alter the equilibrium. It will make the reactions to attain the equilibrium faster rate. For example, we'll imagine that this reaction which is happening in the presence of the catalyst. So this equilibrium value, it might have taken 10 minutes to attain this equilibrium value. Simply I am giving the time. Okay. So now when it comes to second condition, in the absence of the catalyst, reaction might have reached to the equilibrium, but it might have taken 2 hours. It might have taken 2 hours. So what is happening here? So Kc prime, equilibrium is there, no doubt. But this one has been taken in 10 minutes, but that one has been taken in 2 hours. So therefore, catalyst will enhance the rate of the reaction, but will not alter the equilibrium. Fine? So that's what I can tell. So catalyst will increase the rate of the reaction. Rate of the reaction, but will not alter the equilibria. Okay, but will not alter the equilibria. Okay, so that is the conclusion what we can draw. Fine. So any doubts with respect to this one? With respect to impact of catalyst on the chemical equilibrium, any doubts? Okay. So what is the impact of catalyst on equilibrium? It will help to attain the equilibrium faster rate, but it will not alter the equilibrium. Okay. So that is the impact of the catalyst on the equilibrium. Okay. So what and all we have discussed? We have discussed about the factors which will impact the chemical equilibrium. So which are those factors which we have discussed? We have discussed about concentration, right? Then we have discussed about temperature. Then we have discussed about impact of pressure. Naturally, pressure is applicable especially when we are dealing with gaseous molecules. Okay? And the final one is catalyst. So these are the 4 factors which majorly we have discussed with respect to factors which are going to have the impact on the equilibrium. Hagadre, one thing I will make it very clear. Whatever the concentration you might have changed, whatever the temperature you might have changed, whatever the pressure you might have changed, but at the end, reaction has to reach to equilibrium. Fine? Right? Yes, Prithvi. Pressure and catalyst. But one thing I will make it clear, whatever the condition you apply, whatever the alteration you do, but at the end reaction will try to attain equilibrium. All of you will agree with me? A process has to reach to the equilibrium. Whether it is by enhancing the forward reaction or by enhancing the backward reaction. But at the end, it will reach to the equilibrium. Clear? All of you got my point, what I wanted to tell? Right? For example, we had a reaction as I have discussed, A plus B getting converted into C plus D. Whatever the condition you alter, okay? So, in the beginning, it was like Kc is equal to C into D divided by A into B. So, that was the equilibrium. Now, when you alter the condition, the equilibrium might have become like A into B, C into D. That means I am talking about backward direction. So what I mean to tell here is, whatever the condition you alter, reaction will reach to the equilibrium in one or the other way, no doubt. Right? So if it is in forward, this will be the equilibrium. If it is in the backward direction, this will be the equilibrium. But in both the cases, reaction has reached to equilibrium. Fine? So that is the final conclusion what we can draw. Okay? So therefore, we have a principle which is called as Le-Chatler's principle. We have a principle called as Le-Chatler's principle. Okay, na? What is this Le-Chatler's principle talks about? It tells that by altering the condition, when we are going to disturb the equilibrium, the system will try to attain the new equilibrium to nullify the impact of this alteration. Or, for example, I have a reaction. So this was the equilibrium value what we have got. Now what we have done is we have added from outside some more amount of C and D. So now what will happen? Now the reaction will readjust itself in such a way that it will try to compensate whatever extra C and D we have added. So it will shift towards the backward direction. Ashish, I think it will be full. We will finish it off. Okay, we will finish it off this chapter. This week we will finish it off. Okay, now? Anyway, so when I am talking about Le-Chatler's principle, if I apply that one here, Ashish, listen to me here first. So when I am talking about the reaction, it has attained the equilibrium. This is the expression for the equilibrium. Now what I will do is from outside I will add the products. So naturally equilibrium will get disturbed. So to nullify that disturbance, it will move towards the backward direction. So a new equilibrium we have got. Fine. So that's where we have the Lee-Chatler's principle. What is that Lee-Chatler's principle talks about? Lee-Chatler's principle tells that by altering the condition, what is that condition? It can be concentration, it can be pressure, it can be temperature, right? Whatever it is. By altering the condition, when equilibrium will going to be disturbed, so reaction will adjust in such a way that, or it will attain the new equilibrium, try to attain the new equilibrium in such a way that to nullify the impact of these changes. So that's what the Lee-Chatler's principle talks about. Fine. Very important. It has huge application in chemistry. Lee-Chatler's principle. Any doubts? If you have any doubts, you can ask. Okay. Then I was talking about last class reaction quotient and equilibrium constant and all, right? Now, if I want to have the application of reaction quotient, what can be the application of reaction quotient? The major application of reaction quotient is it's going to have influence, or it will give the information on condition of the reaction, whether forward reaction is happening or whether backward reaction is happening or reaction has reached to the equilibrium. That's what the information we are going to get by calculating the reaction quotient or equilibrium constant. For example, we have a reaction A plus B getting converted into C plus D. For this reaction, Kc value is somewhere around 20. Simply I am giving the values, it will be 20. What I mean to tell here is, Kc value when it is 20, that shows that there is no further change in the reactant concentration and product concentration. It has reached to the equilibrium. Fine. Now, this reaction is happening. Okay. In between, while reaction is going on, we will check the concentration of these two. Then I will take that one as Qc value. Qc value is somewhere around 10. Qc value is somewhere around 10. So what it indicates? Whether forward reaction will be happening, now onwards, or backward reaction will be happening. Kc value will be 20. Once this reaction will reach to equilibrium, Kc value has to be 20. That we know. Okay? But for time being, we have not calculated this one. We want to see what is the condition of the reaction. Reaction is happening. Now we found the concentration of C and D, A and B in between. Then we have found the Qc value. And Qc value we have got it as 10. What is Qc? Qc is equal to same as that of the Kc only, where concentration of C, concentration of D divided by concentration of A and concentration of B. But these concentration may not be at equilibrium. That's why Qc and Kc differs. Okay. Now Qc value we have got it as 10. Now you should tell me whether next onwards reaction will be forward or backward. Just type it as forward or backward. That's all. What will happen? Yes, very good, very good. So naturally Qc value is less than Kc value, so it has to be in forward direction. It has to be in the forward direction because Qc value is less than the Kc. So reaction will be moving towards the forward direction. exactly opposite will happen when QC value is greater than Kc. Then naturally backward reaction is going to happen. Due to the condition what we have provided, this might have taken place. So where we found that QC is greater than Kc, then the backward reaction is going to happen. Okay? So when QC is going to be equal to Kc, that shows that system or reaction has reached to equilibrium. Reaction has reached to equilibrium. Fine? All of you have understood? Any doubts with regard to this one? Okay? Fine. That's where we have the reaction quotient and equilibrium constant value, which will brief the condition of the reaction. Whether how much time reaction will take to reach to equilibrium, or what is that condition we should change to make this reaction to happen in the forward direction. All these things can be understood once we find the equilibrium constant and reaction quotient of that particular reaction. Fine. Now we will come to the next part, which you people have studied in your high school, 10th standard only, right? So that is acids, bases. Okay. So we are going to discuss about majorly these two, acids and bases. Correct. To discuss about these molecules, because in the nature we have acids and bases, molecules are present in the nature. So now to discuss about these molecules, first we should be knowing three important theory which talks about these two molecules. First one is Arrhenius theory. First one is Arrhenius theory. Okay, and the next one is Bronsted-Lowry theory. Next one is Bronsted-Lowry theory, and the last one is Lewis theory. Last one is Lewis theory. Right? What is that Arrhenius theory talks about? According to Arrhenius theory, acids are H plus donors and bases are OH minus donors. So what are acids? Acids are H plus donors and bases are OH minus donors. Right? So that's where we have the Arrhenius theory, which talks about acids and base. So according to that, what are acids? Acids are H plus donors and bases are OH minus donors. If I want to take the example, now HCl, sulfuric acid, nitric acid, all of them, they are going to give the H plus. So therefore they are acids. Right? If I take sodium hydroxide, they can be considered as base because they are going to release the OH minus. They are going to release the OH minus. Sodium hydroxide or calcium hydroxide or potassium hydroxide. So that's where we have the bases. That's where we have the Arrhenius theory. But if you observe it carefully, now we know that even ammonia is considered as a base. That we know now. Ammonia is a base. But if you observe it carefully, ammonia is not going to release any OH minus. Ammonia is not going to release any OH minus. But according to Arrhenius theory, bases should be releasing the OH minus. Based on that, according to Arrhenius theory, ammonia cannot be a base. That is the drawback of Arrhenius theory. It's not applicable for all the molecules. Fine. But in the examination, if they ask Arrhenius theory, then you should tell that acids are H plus donors, bases are OH minus donors, and these can be the some of the examples. Fine? Whether I am clear? Any doubts? Okay. So when it comes to Bronsted-Lowry theory, so by understanding this drawback in Arrhenius theory, he wanted to give a little bit broad view. He wanted to talk about in a broad sense about the acids and base. So what he told is acids are H plus donors, that means he kept it same as that of the Arrhenius acids only. But when it comes to bases, he told that bases are H plus acceptors. H plus acceptors. That's what Bronsted-Lowry theory talks about. Acids, with respect to definition of acids, both are same. But when it comes to definition of base, there is a change. So according to Arrhenius theory, bases are OH minus donors, and Bronsted-Lowry theory, bases are H plus acceptors. So that means now ammonia can be considered as a base. Now ammonia can be considered as a base. Why ammonia can be considered as a base? Because it's going to accept the H plus and it will become ammonium. Right? So it's the H plus acceptor. So therefore we can call it as a base. Fine? But while explaining that one, so therefore if I want to tell that naturally HCl, sulfuric acid, all of them, they can be considered as acids, and ammonia can be considered as a base. Now the question here is, according to Bronsted-Lowry theory, bases as a molecule should accept the H plus. But sodium hydroxide, if I consider the sodium hydroxide as a molecule is not going to take up the H plus. Please remember, sodium hydroxide as a molecule, it will not pick up Na H plus. It will not become NaOH twice. Right? As a molecule, it is not possible. Sodium hydroxide to take up the H plus. But still, it is known that sodium hydroxide is a strong base. So that's where Bronsted-Lowry theory is some problem. Right? So what I mean to tell you is, according to Arrhenius theory, yes, sodium hydroxide can be considered as a base because donors of OH minus. But according to Bronsted-Lowry theory, sodium hydroxide, there is a confusion because as a molecule sodium hydroxide is not going to take up the H plus. But once it is dissociated, once sodium hydroxide is dissociated, Na plus OH minus. So this OH minus is going to take up the H plus to become water. Neutralization. Right? So that's what Bronsted-Lowry theory will create a confusion with respect to sodium hydroxides. Fine? But if I observe, definition wise, acids are H plus donors, bases are H plus acceptors. Ashish, both the theories, they are important, acceptable, but in between there is some loophole. So that's why so many theories have been existing. But all of them, they are important. It doesn't mean that Arrhenius theory is better than Bronsted-Lowry theory or Bronsted-Lowry theory is better than Arrhenius theory. Not like that. All of them, they are equal importance. Fine? But if you take with respect to broad sense, then Lewis theory will be a broad one. It will cover all the acids and all the bases. For example, according to Lewis theory, acids are electron acceptors. Acids are electron acceptors. And bases are electron donors. Bases are electron donors. So that's where we can talk about the Lewis in a broad sense. For example, if I take earlier one, like ammonia, will be considered as a Lewis base because it will donate its lone pair of electron. So natural ammonia will be considered as a Lewis base, and the acceptor of this electron can be an H plus, which can be a Lewis acid. H plus can be a Lewis acid. Any molecule which is going to take up the electron can be considered as a Lewis acid. Any molecule which is going to donate the electron will be considered as a Lewis base. For example, in this case, ammonia is a Lewis base, H plus is a Lewis acid. Same way. Darshan, yes, bases are proton acceptors, that I agree. So, according to Lewis acid I am talking about, Lewis theory I am talking about. According to Lewis theory, acids are electron acceptor. So, that's what H plus is doing here, it is accepting the electron. And bases are electron donors. So, that's what ammonia is doing here, it is donating the electron. So, according to that, ammonia should be a Lewis base and H plus should be the Lewis acids. Fine. So that's where we have the Lewis theory. Or if you go back to Friedel-Crafts reaction, if you observe the catalyst over there, it will be either aluminium trichloride or ferric chloride, right? So which type of catalyst it will be considered as? Friedel-Crafts reaction, it will be considered as a Lewis acids. It will be considered as a Lewis acids. So therefore, if you remember, it helps in the cleavage of the chlorine molecule to undergo heterolytic cleavage, where there will be formation of chloronium ion and chloride, and this electron will be taken care by the aluminium chloride, right? So electron acceptors. Got my point? So that's what. So aluminium trichloride, where aluminium is in its highest oxidation state, that is +3, can act as a Lewis acid. Got my point? Same way, nitric acid, HNO3, where nitrogen in its highest oxidation state. So therefore HNO3 can act as a Lewis acid. So because of that I am telling that Lewis theory is like a broad one. It is applicable for all the acids and all the bases. So according to that, acids are electron acceptors and bases are electron donors. Fine. So that's what Arrhenius theory, Bronsted-Lowry theory and Lewis theory. Arrhenius theory, acids are H plus donors, bases are OH minus donors. According to Bronsted-Lowry theory, acids are H plus donors, bases are H plus acceptors. And when it comes to Lewis theory, acids are electron acceptors and bases are electron donors. Okay? So you can take the example. Example can be Lewis acids can be taken as the example of aluminium chloride. And for bases, we can take it as ammonia as the Lewis base. Okay? You can give plenty of examples. Any doubts with regard to this one? Any doubts? Okay. So definition and example and all you can expect from this part in your exams. Okay? So that's where we have the different theories which will explain the acid and bases. Now we will move to next one. Give me another 5 minutes. Now we will move to next one. Fine. Diborane. Yes, Darshan. It can be the example. Yes. B2H6. Yes, because there is electron deficiency, right? So there is a electron deficiency. Fine. So Hagapi will move to the next one. Equilibrium means next concept. Any doubts with regard to earlier one? Okay. So next one is related to pH scale. Next one is related to pH scale. And all of us we know pH scale will be ranging from 0 to 40. So 0 to 40. Right? So that's what we know. It is 0 to 40 pH scale. Now what is pH actually? That one everyone knows that it is negative log of H plus concentration. Negative log of H plus concentration. Fine. So that's where we have the pH value. Hagadre, if that is the case, if pH value is minus log of H plus concentration, which can also be written as log of 1 by H plus, anything is fine. 1 by H plus, anything is fine. So that's where we have the pH, which talks about the concentration of hydrogen ion concentration in a solution. That's where we have the pH. So where the value will be ranging from 0 to 40. Right? 0 to 40. If that is the case, how pH scale is controlled by these values only? Why cannot be pH value cannot be beyond 14? Why it should be 14? It has to stop. Right? That will be the question. Who will going to decide that pH value should be 0 to 14 only? Why not 16? Why not 17? Or why not 18? So that will be the question. Right? So now we know that pH value or pH scale will be 0 to 14 because whatever pH scale is that, it is based on the ionic product of water. It is based on the ionic product of water or ion product of water. So which will be denoted by Kw. So that's what we know now. So due to that, pH scale is 0 to 14. It is not more than 14. It cannot be more than 14. Fine. Any doubts? What is that ionic product of water and all? We are going to discuss in the next class. But for time being, any doubts? So this is where we have the pH scale. But tomorrow anyway, we are going to discuss that and we will solve some problems related to pH calculation, which can be asked for 1 marks or 2 marks. Fine? Any doubts related to today's class? Any doubts? Okay, so no doubts. Okay, then I will stop here. Tomorrow we are going to solve some of the problems related to pH calculation. Fine? Okay then. Thank you. Thank you very much. Take care. Bye. Okay, thank you.